Hello everyone, I welcome you all to the second lectures on circles. In this lecture, we'll be discussing the theorems and properties pertaining to circle. In the last lecture, in the circles one, what we discussed was the basic things about circle, like how do we define a circle, what are the basic parameters regarding a circle, for example, what is a chord of a circle, what is segment of a circle, what is sector of a circle, what is arc of a circle, and we also understood how can we calculate all those parameters. In this lecture, we're going to go a step further and we'll be understanding some theorems and properties pertaining to circle, which will be helpful for us in order to solve the questions. Okay, so you're going to look at the theorems or the properties one by one, and I'm going to make you understand what exactly they say and how we can use them. All right, so let's get started. So the first one is the same segment theorem. Now, what exactly is same segment theorem? Let's understand it. So the same segment theorem goes something like this. I'm going to try to put this in as simple way as possible. So let's say AB is a chord in a circle. Okay. If AB is a chord in a circle, I can say the area below it, I can call the region below it as segment 1, and the region above it, I can call that as segment 2. Okay. So if AB is a chord of a circle, and this chord makes an angle theta at the center of the circle. Now this is the center of the circle as I've marked O. So let's say this angle is some angle theta. So AB is a chord of a circle, and this chord makes an angle theta at the center of the circle. Then this same chord will make an angle of theta by 2 in the same segment of the circle, provided that the third point lies on the perimeter of the circle. So what do I mean by all this? So AB is a chord, AB is making an angle theta at the center of the circle. Now we can also all say that the center of the circle lies in segment 2. So what this theorem says is, if you pick any point in segment 2, provided that it lies on the circumference. For example, let's talk about these 2 points P and Q. P and Q both lie in segment 2, P and Q both lie on the circumference. So the angle made by APB and angle made by AQB will be equal to theta by 2 degrees. This is what the theorem says. If a chord makes an angle theta at the center of the circle, then the same chord makes an angle of theta by 2 in the same segment of the circle, provided that the third point lies on the circumference of the circle. So if, for example, let's say we remove all this, I'll just be requiring A and B. Let's say if I draw a random line, let me connect this with B. So let's say this point is C. Now this point C lies in the same segment as that of O. However, this point C does not lie on circumference. So this angle here, which is angle ACB, this is not equal to theta by 2, and it is given to us that angle AOB is theta. This is not theta by 2. So two conditions. One is the point should lie in the same segment and the point should lie on the circumference. These are the two things. Okay. Similarly, I can also say that if I talk about this angle, that is angle ARB. Now this point R lies on the circumference, no doubt in that, but this point R does not lie in the same segment. So again, you cannot say that angle ARB will be equal to theta by 2. This is not theta by 2, provided that angle AOB is theta. So this is what we need to remember. So if a chord makes an angle theta at the center of the circle, the same chord makes an angle theta by 2 in the same segment of the circle, provided that the third point lies on the circumference of the circle. Okay, so using this theorem, we can say that angle in the same segment are always equal. The conclusion which is important is angles in same segment or let me make this more specific. Made by a chord are equal. So you can say that angle APB is equal to angle AQB, or for example, if you draw any third chord also, let's say something like this. So let's say this point is S, so that will also be equal to angle ASB. So angles in the same segment made by a chord are always equal. So that's why this theorem is known as same segment theorem, that the angles in the same segment are always equal. So I hope this theorem and this property is clear to everyone. Now, we make use of this theorem when we say that angle in a semicircle is equal to 90 degrees. How? Let's try and understand. So here we are taking a semicircle. Let's name the points first of all. This is A, this is B, and this is B. Now AB here is acting as a diameter, right? AB here is acting as a diameter. Now it's a diameter, it's going to be a straight line which is going to pass through center of the circle. Now it's a straight line passing through the center of the circle. So I can say a straight line makes an angle of 180 degrees. So this angle here will be equal to 180 degrees. So this chord, which is the diameter, is making an angle of 180 degree at the center of the circle. So it's going to make an angle of 90 degrees in the same segment of the circle. So I can say that this angle here would be equal to 90 degrees. Or for that matter of fact, you take any angle. This is always 90 degrees. All this P1, you can take it in the other semicircle also. This is also 90. This is also 90. Let's call them Q1, Q2. So angles in the same semicircle is always equal to 90 degrees. Alright. So I hope both the things are clear to us. So we'll try a question. So let's try this one. So why don't you pause the video, try the question yourself, then you can play it back in order to understand how to solve this question. Alright, let's see what we can do with this one. Let's say that in the figure given below, O is the center of the circle, then find the measurement of angle ABC. Alright. Now, O is center, which means one thing is sure, that AC will be the diagonal or the diameter basically. And this angle here will be equal to 180 degrees. Apart from that, I do not know anything in this figure. So what can we do? Now I know one thing. If this point B were to lie on the circumference, let's say this B dash, and if I connect B dash with C, then I can say one thing for sure, that angle AB dash C will be definitely equal to 90 degrees, because B dash lies in the circumference, and if a chord makes an angle theta at the center of the circle, it's going to make an angle of theta by 2 in the same segment of the circle, provided that the point lies on the circumference of the circle. We know this property. So if AOC is 180, AB dash C has to be 180 by 2, which is equal to 90 degrees. Okay, now what we can do? So let's do one thing. Let's say that angle A is equal to X degrees. Now B is already 90, sorry, B dash is 90, which means I can say that angle C will be equal to 90 minus X, because we all know that sum of the angles in a triangle adds up to 180 degrees. Okay, so if B dash is 90, A is X, then C has to be 90 minus X, that's for sure. Now understand this part. If I bring B dash to B along the line B dash B, what I'm saying is if I bring B dash to B along the line B dash B, can I say my angle A won't change? Because the angles between the line AB and AC is not changing, it's just that I'm reducing the dimension of AB dash. So angle A won't change, that's one thing for sure. At the same point of time, I can also see that angle C is gonna reduce. So angle C is gonna reduce by this much amount. You can see it in here. So angle C is going to reduce by this much amount. Now angle A is constant. Understand this, angle A is constant, C is reducing. I know that sum is 180. So let me put it this way. Three things are there. Let's say P plus Q plus R. Now let's name them A, B and C only, so that you can relate. Okay, the sum is 180. I am reducing this quantity. Sorry, this is constant, my mistake. A is constant. I am reducing this quantity. Okay, I'm reducing this angle. One of the angles is constant, one of the angles is reducing, and I have only three angles. Or let me put it this way, the sum of three things is 180, one of them stays constant, the other is reducing. What's going to happen to the third thing? Exactly, the third thing is going to increase. So B is going to increase for sure. B is going to increase for sure. Now, by what amount it's going to increase, that's not my concern. It has to be given to me in the question. As of now, I have not mentioned it because this question is more about concepts, okay, not the answers. So what I'm saying is A is constant, C is reducing, so that means B has to increase. So this angle that you see ABC, this angle here, this angle has to be greater than 90. This angle has to be greater than 90. Okay, now by what amount, that would depend upon that by what amount C is decreasing. Anyways, let's not go into that. The point is angle B will be greater than 90 degree. So your answer is simply that ABC has to be greater than 90 degree, that's for sure. So you're going to have four options in the exam, that is equal to 90, less than 90, greater than 90, or cannot be determined. Your answer is greater than 90. Cannot be determined is not the correct answer that you're looking for. Alright, so I hope this question is clear to everyone, as well as the concept is also clear. Alright. Okay, so the next thing that we need to understand is this term cyclic quadrilateral. And before we understand what exactly is a cyclic quadrilateral and the property that you need to remember of cyclic quadrilateral for the exam, you first need to understand what is a quadrilateral. So when you talk about this term quadrilateral, it's basically a polygon with four sides. The next question comes in, define polygon. So polygon is any closed figure made up of straight lines. Okay, it's any closed figure which is made up of straight lines. So the smallest polygon that you have is triangle, and then it keeps on going on. So quadrilateral is the second smallest polygon, which is basically made up of 4 sides. Okay, now what's a cyclic quadrilateral? So cyclic quadrilateral is a quadrilateral whose all the 4 vertices lie on the circle and it is inscribed in a circle. Cyclic quadrilateral is a quadrilateral inscribed in a circle whose all the 4 vertices lie on the circumference of the circle. For example, the green quadrilateral that you see on your screen, let me name it also. So this A, B, C and D. So this is a cyclic quadrilateral. Okay, so cyclic quadrilateral is a quadrilateral inscribed in a circle and whose all the 4 vertices lie on the circumference of the circle. Similarly, the black quadrilateral that you see, let me name it PQRS. This is not a cyclic quadrilateral because S does not lie on the circumference. So 2 things are important. Please make a note of them. It should be inscribed in a circle. All 4 vertices should lie on the circle. Okay? These are the 2 things which you need to remember. These are the 2 things which basically define a cyclic quadrilateral. Now the property which you need to remember for your exam is that, let me remove PQRS first of all. So the property is the sum of the opposite angles in a cyclic quadrilateral adds up to 180 degrees. Sum of the opposite angles in a cyclic quadrilateral adds up to 180 degrees, which means you can say that angle A plus angle C is equal to 180 degrees and angle B plus angle D is equal to 180 degrees. These are the 2 things which you need to remember for a cyclic quadrilateral. Alright, now alright, so why don't we try a question? We can start with this question number 2. So again, for the same drill, pause the video, try the question yourself, then play it back in order to understand how to solve the question. Alright, let's try this one. So in the figure given below, O is center of the circle and angle ACO is 20 degrees. So what is angle ACO? First of all, you need to first connect A with C. And this angle here is equal to 20 degrees. You need to find the measurement of angle ABC in degrees. Alright, so how we can do this one? Let's see. Now let's first concentrate on triangle ACO. When you concentrate on triangle ACO, you realize that AO is equal to CO because they both are acting, they both are basically the radius of a circle. So which means they are equal. Now in a triangle, there is this basic property which everyone knows, that is angles opposite to equal sides are equal. Angles opposite to equal sides are equal. So if ACO is 20, then CAO has to be 20 also. Then CAO has to be 20. Now sum of the angles in a triangle is 180. So 20, 20, 40, that means this has to be 40. So this has to be 140. 20, 20, 40, 180 minus 40 is 140. Okay, now we need to find out ABC. Now you can see that ABCO is not a cyclic quadrilateral, right? Because O does not lie on the circumference. So we can't use that property that O plus B will become 180 and B will be 40. That would be incorrect. So what can we do? In this question, we'll have to do a little bit of construction. So what we need to do is, we're going to select a point somewhere here and we're going to connect it with A and C. Now if you'll observe carefully, you'll realize that AC is a chord of a circle. AC is a chord of a circle which is making an angle of 140 at the center of the circle. It's just that the figure is inverted, but the concept remains the same. AC is a chord and it's making an angle of 140 at the center of the circle. So the same chord is going to make an angle of 140 by 2, which is like basically 70 degrees in the same segment of the circle. It's going to make an angle of 70 degrees in the same segment of the circle, right? Provided that the point lies on the circumference of the circle. So P and O lies in the same segment, P also lies on the circumference, which means APC is 70 degrees. Now if you'll observe carefully, you'll realize that ABCP is a cyclic quadrilateral, which means B plus P is 180, and which means angle B will be equal to 110 degrees. So this is how you can use this concept. So I hope we are clear with this question. Alright, let's move on to the next thing. So the next thing that we need to discuss is the alternate segment theorem. Okay, now before we understand what is an alternate segment theorem, we need to understand this concept of tangent. What exactly is a tangent? Okay, so let's first discuss that, then we'll move on to the theorem. So when you talk about this term tangent, so tangent is basically a line or a line segment which is drawn from a point outside the circle and it touches the circle at one point and makes an angle of 90 degrees with the radius of the circle. Okay, I'll repeat again. It's a line or a line segment that is drawn from a point outside the circle such that it touches the circle at one point and makes an angle of 90 degree with the radius of the circle. So let's concentrate on this figure 2. So P is this point which is outside the circle. I've drawn a line segment from this point P which touches the circle at point L1 and L2 such that this PL1 is making an angle of 90 degrees with OL1, and let's call this PL2. This is making an angle of 90 degree with OL2. This is how we define a tangent. Okay, it's a pretty simple thing. It's simply a line or a line segment that is drawn from a point outside the circle which makes an angle of 90 degree with the radius of the circle. Now what you need to also remember is that from a point that lies outside the circle, you can draw only two tangents to a circle. From any point that lies outside the circle, you can draw only two tangents to a circle. Like from this point P, the two tangents which are possible I have already drawn, which is PL1 and PL2. You cannot draw one more tangent from this point P. Okay. Similarly, I may have taken another point Q which lies outside the circle. So from that point Q again you could have drawn only two tangents. Okay. For example, something like this. Let's call this Q, let's call this M1, let's call this M2. Okay. So from any point that lies outside the circle, you can only draw two tangents to a circle. Okay, remember this. Now another important thing regarding tangents which you need to know. So let's talk about this triangle PL1O. This is radius, let's call this R. Let's call this PO as some distance D. And since this angle is equal to 90 degrees, so I can use the Pythagoras theorem in triangle PL1O, and I can say that PO square is equal to PL1 square plus OL1 square. So you will say that D square, and let's do one thing, let's call PL1 as X, that it's easier for us to do calculation. This will become x square plus r square, and from here I'll get x is equal to under root of d square minus r square. So what is x equal to? X is equal to under root of d square minus r square. Now let's do one thing. For this triangle POL2, let's call this PL2 as y. So again I can say that PO square is equal to OL2 square plus PL2 square. So I'll get that d square is equal to y square plus r square, and y will be equal to under root of d square minus r square. Now you'll observe that the value of x and y is equal. So another thing which you need to remember, that from a point that lies outside the circle, the two tangents drawn are always equal in length. Okay, from a point that lies outside the circle, the two tangents drawn to a circle are always equal in length. So PL1 is equal to PL2. Similarly, we also drew QM1 and QM2, so they both will also be equal. Okay. So this is what you need to know regarding tangent, and this is the property that you need to remember regarding the tangent. Okay, now let's move on to this alternate segment theorem. So what does this say? Let's see. So first of all, I would like to name these points. So let's say this is A, this is B, this is C. And let's say this line is L1. Okay. Now AB is a chord of a circle. So let's say the area above it is segment 1 and the area below it is segment 2. Okay. Area above it is segment 1 and area below it is segment 2. So what this alternate segment theorem says is that, let's say a chord of a circle and a tangent to a circle makes an angle of theta in one segment of the circle. So this L1 is a tangent and it's tangent at point A. So let's say in segment 1 they make an angle theta. So chord of a circle and tangent to a circle makes an angle theta in one of the segments of the circle. Then the same chord will make an angle of theta in the opposite segment of the circle, provided that the point lies on the circumference of the circle. So let me put this in simple words for you. AB is a chord. AB and this tangent L1 is making an angle theta in segment 1. AB and this tangent L1 is making an angle theta in segment 1. If you pick any point in segment 2, provided that it lies on the circumference, and if you connect that point with A and B, then the angle formed will also be equal to theta degrees. So hence angle ACB is equal to theta degrees. Similarly, you could have taken any other point. For example, I could have taken some point like this. And this will also be theta degrees. Let's call this D. Or for example, let's call the C. This is also theta degrees. Okay, this is what you need to remember regarding the alternate segment theorem. Okay. Alright, so one last thing that we need to do, which I think we already have discussed in the last lecture, but anyways, let me remind you this. This is another important property for your exam. So this property goes something like this. I'm gonna put this into like a simple mathematical expression so that you remember this. Okay. So it goes something like this. AB is a chord. Now let me first write what all is given to me. So first thing that is given to me that AB is a chord. Second thing that is given to me is that O is the center of the circle. Okay. Now there are two ways of understanding this. First way is AB is a chord and O is center of the circle. If you connect O with midpoint of the chord, if you connect O with midpoint of the chord, let's call the midpoint to be P. If you connect O with midpoint of the chord, then the angle made by OP with AB will be 90 degrees. That is, this angle is 90 and this angle is also 90. So AB is a chord, O is the center of the circle. If you connect O with midpoint of chord, which is P in this case, then the angle OPA and OPB will be equal to 90 degrees. The converse of this is also true. That is, the converse is AB is a chord, O is the center of the circle, and let me write the second part here with a different color. And OP is perpendicular to AB. AB is a chord, O is center of the circle. OP is perpendicular to AB. This will only happen, or let me put it this way, if this happens, then P is midpoint of AB. So it goes basically both the ways. If it is the midpoint, then the angle is 90. If the angle is 90, then it is the midpoint. Okay. So these are the properties which you need to remember. Alright. So we'll be taking up like a couple of questions probably in the next lecture so that you're able to understand like how to use these theorems or these properties basically. Alright. So that will be all for this lecture. Thank you so much. Keep watching and keep learning.